Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Fatul Akbar and I will explain about Egyptian arithmetic. The following are the Egyptian mathematics numbers hieroglyphs. Okay, addition and subtraction. The techniques used by the Egyptians for this are basically the same as those used by modern mathematicians. The Egyptians performed the addition operating by combining symbols and subtraction symbols for the subtraction operation. For example, you can see on my presentation, we will merge or subtract all units together, then all tens together, and all hundreds together. Okay. Multiplication and division. The Egyptian arithmetic was essentially additive, meaning that its tendency was to multiplication and division to repeated additions. Multiplication of two numbers was accomplished by successively doubling one of the numbers and then adding the appropriate duplication to form the product. Okay, for the example, 19 times 71, we can write like this. These numbers are the result of multiplying 2 from the previous number. And we stop at 16 because this number is the largest number close to 19 and there are already numbers that add up to 19. After that, we choose the number that add up to 19 like this, and next we add the numbers that are parallel to it and the result is 1349. How about divide? For ancient Egyptian divisions, the process is the same as multiplication. The difference is if the multiplication that is considered is the smallest number, while in division, what is considered is the largest number. Okay, next the unit fraction. Okay, next the unit fraction. As we know, a fraction number is a number consisting of a numerator and a denominator. The first fraction appeared around 1600 BC. At the beginning of the Rhine papyrus, there is such a table giving the breakdown for fraction with numerator 2 and denominator an odd number between 3 and 101. This a table from the Rhine mathematical papyrus. From the table, we know that ancient Egyptian society only recognized unit fractions, where n is a positive integer and the numerator is 1. A fraction other than a unit fraction is stated as the sum of two or more different unit fractions. Okay. Next, representing rational numbers. There are several ways of expanding a fraction with numerator other than 2 as a sum of unit fraction. For example, we can use 2 over n table from Rhine papyrus. The example like this. But calculating fractions with a numerator of more than 2 is not necessarily correct when using the 2 over n table. Over time, there are several modern ways of expanding a fraction with numerator other than 2 as a sum of unit fraction. Those methods are splitting method and Fibonacci's method. Okay, first, the splitting method. This method breaks the fraction into a sum of several fraction units. The formula is, as you can see on my presentation. Okay, and I give an example. 3 over 4, it's equals to 3 of a quarter. This method already in the form of a unit fraction, but in the splitting method, the unit fraction must be different. Therefore, we will change 2 out of 3 numbers using the splitting method formula, like this. Okay, and it's equals to, and see my presentation. Okay, and and in this case is the same as the previous one. Okay, and there is a result of 3 over 4 by using splitting method. And the second is Fibonacci method. The second technique we want to consider is credited to the 13th century Italian mathematician Leonardo of Pisa, better known by his patronymic Fibonacci. In 1202, Fibonacci published an algorithm for expressing any rational number between 0 and 1 as a sum of distinct unit fractions. This was rediscovered and more deeply investigated by J. Sylvester in 1880. The idea of Fibonacci is like this, and to determine n1 in such a way that, like this, and the formula is there. Okay, I wanna, oh, okay, and in the hint, if a1 is not equal to 1, then we will look for a 2, a 3, and until until the value is 1. Okay, for the example you can see on my presentation. Okay, that's all about my presentation. Thank you.